All right, we're back for another short video, this time talking about quadratic functions. So quadratic functions, you should be pretty well familiar with these at this point. So basically, it's a polynomial function of highest degree 2. They can be written in either factorized or expanded form. So you can see on the left here, quadratic written in expanded form, so descending powers of x. We have ax squared plus bx plus c. A, b, and c are constant terms. Then we have factorized form over here. That's where we write it as a product of linear factors. So, or as simple as we can get. So we have x plus b plus, what's all this? Well, this here is the quadratic formula. So if we need to find the roots, which is the solutions to when is this thing equal to 0, when is that equal to 0? Well, it's equal to 0 when x is equal to this value, negative b plus or minus the square root of b squared minus 4ac over 2a. The plus or minus means we're going to have a positive or negative solution. So two solutions could possibly be one solution if this thing is equal to 0. We'll get to that in a minute. The point is you should memorize this equation if you haven't already done so. It's very important. You won't be given it on a formula sheet. You need to have it embedded in your minds. So notice that because we have a square root there, that term there, we call that the discriminant. So if that value underneath the square root sign, if that is greater than 0, we're going to have plus or minus some number, which means we're going to have two solutions. And if that is equal to 0, then we're going to have plus or minus 0 because the square root of 0 is 0. So therefore, there's going to be one solution. And if it's less than 0, then we're not going to have any solutions at all because we remember the square root of a negative does not exist for real numbers. So we don't need to worry about that. So they're the three possibilities. There's either one solution, two solutions, no solutions. That basically translates to, if we were to draw a straight line, let's type in y equals x squared plus c, and I'll play around with the value of c. You can see if c is equal to 0, let's say, you can see there's one solution right there. There's the solution. If c was equal to, let's say, negative 5, you can see there are now two solutions. There they are. And if c was equal to, say, 7, you can see there's no solutions because this parabola does not pass through the line here. So they're the cases. Now, we need to know how to factorize quadratic equations. So we go through a procedure. Step 1 is we check to see if there's a highest common factor. If there is, we can just take it out. So for example, if we have the equation 2x plus x squared, notice that both of these terms can divide by x. So if we divide them both by x, we can take out x as the factor, and we're left with 2x divided by x, which is 2, and x squared divided by x, which is x. So that's factorized there. So that's one way of factorizing. That's the easiest way. Second thing is to look for patterns. We can look for what's called a difference of two squares, or a dots pattern, or a perfect square pattern. So a difference of two squares, basically it looks like a squared minus b squared. So for example, if we have, let's say, x squared minus 4, we know that 4 is the same as 2 squared, right? So we could write this as x squared minus 2 squared. Therefore, this would factorize as x plus 2, x minus 2. Now, a lot of people get confused about this, and they're going to think that a squared minus b squared is not going to be equal to this, or more specifically, a lot of people make this particular mistake with perfect squares. They will, if they're trying to factorize, let's say, x plus 2 squared, a lot of people say the answer is this, x squared plus 4, because they just go, well, it's x squared plus 2 squared, so therefore the answer is x squared plus 4. That's not how we do it. So perfect squares come about because we have this rule with factorizing and expanding that's called FOIL. We have, let's call them a and b. A plus b times a plus b. That's what squared means, times the number by itself. We can go FOIL for this. So let me show you how that works. We're going to go first terms, outer terms, inner terms, last terms. So if we have a look at that, the first two terms are going to be equal to a times a, which is a squared. The outer term is a times b. The inner term is b times a. And then the last term is b times b. Okay, now we notice these two terms are identical to each other, so therefore we can write this as a squared plus 2ab plus b squared. So that is how we would expand one of these guys here. And as you can see, it is not equal to a squared plus b squared. So do not make that mistake. Okay, that's perfect square patterns. So look out for those perfect square patterns. For example, if we were to try and factorize, let's say, let's suppose we have x squared plus 2x plus 1. We might notice that that is x plus 1 squared, because this is x squared, this is 2 times 1 times x in that form, and then at the end we have 1 squared, which is just 1. So that would be how we could factorize one of those. Next method is find two numbers that add to give the middle number, and multiply to give the last number, the constant. This only works if we have a monic quadratic, which is to say that the coefficient of x squared is 1. So for example, if we have x squared plus 4x plus 5, what two numbers add to give 4, multiply to give 5? Not sure if there are any, to be honest. Maybe let's try out, try and come up with one off the top of my head. If we have -5, does that work? It's sometimes hard to just come up with an example. Yeah, let's go with 5x plus 4. What two numbers add to give 5 times to give 4? So 1 times 4, that's 4. And 1 plus 4, that's 5. So we could write this as x plus 4 times x plus 1. Okay. If we expand that out, we're going to see that it's the same thing. So yeah, like what we're really looking for here is we're using the fact that when we expand these brackets, we're going to add the two numbers that have like the same coefficients. The two ones in the middle are going to be added together, the two with the same power of x, and we'll end up with a square term at the end. So, which is basically the last two terms. This is just using FOIL. So we know we're going to end up with first, so x times x is just x squared. Outer is going to be 4x plus 1x. So we're going to add those two terms, and we're going to multiply 4 times 1. So that's why we're adding to give 5, multiplying to give 4. So that's the answer there. Another method that we can use for factorization is completing the square. So this is basically where we try and construct a square. So let's suppose we use the fact that a square looks like this. X times x. We have over here 4x. So let's say that this can be 4 over here. So the area of this square here is going to be, the area of this one is going to be x times x, x squared. The area of this one is going to be 4x. Now have a look at what we could do. We could just cut this square in half. So I'm going to cut this square in half, which is to say that I'm going to cut off the first half of it. So let's just, this stylus is not being very good to me. Okay, so, there we go. It's not really the right color, but that's fine. Let us change this. So now this side length here is 2. Let's bring the other side of that square over here. So you can see that together this is 2 plus 2, that makes 4. So these are the two halves of that we had. 2x plus 2x, that's equal to 4x. It's the same thing. If we want to complete the square, what value do we need to add? Well, the value we need to add is going to be 2 times 2, which is 4. So you can see completing the square is the same as taking that number, the coefficient of x, dividing it by 2, and then squaring it, which is why we go plus 4 divided by 2 squared, and then we take away that term, 4 divided by 2 squared. That's what we're doing. This little diagram over here is trying to show you that. So let's just simplify this down. We can see that this square is x plus 2 times x plus 2. So that first part there is going to be x plus 2 squared. And the reason we take it away is to maintain equality so that it stays the same value. So when we take that away, that is going to be, 2 squared, that's equal to 4. And now what we have is what's called turning point form. So we can conclude, looking at this equation here, y equals x plus 2 squared minus 4, that the TP, the turning point, is going to be equal to negative 2, 4. So that's something that you might remember from last year. There are also other methods for factorizing. I would recommend looking up the cross method online. Quickly show you how to do one of these methods. This is the one that I like. This is a non-monic. So how do we factorize non-monics? We could use completing the square. Remember to take out the 2 first. We could use the quadratic formula. I like to use this method. We look at the first term, we look at the last term. They multiply together to make 12. So what I'm asking myself is, what numbers add to give 1, the coefficient of x, and times to give 12. So let's go through the factors of 12. So factors of 12 are going to be, 1 and 12. We could have 3 and 4. I think that's the one we're after. How can we combine 3 and 4 to get 1? Well, maybe if we had a... Oh, no, that doesn't really work, does it? Wait a minute. Let's see. Oh, no, sorry. Yeah, it should be negative 12, isn't it? Because we had 2 times negative 6. So, yeah, if we had factors of negative 12, we could have negative 3 and 4. Negative 3 times 4, that's equal to 12. Negative 3 plus 4, that's equal to 1. So we found it. So it is negative 3 plus 4. Negative 3 times 4 is equal to negative 12. So we seem to have found our answer. So now let's do this. So coming down here, what we're going to do is split this. This is going to become 2x squared plus 4x minus 3x minus 6. We split those two x terms down the middle. Then we factorize the 2 halves. So factorizing the first half, we can take out a factor of 2x. Then we get x plus 2. And then factorizing the second half, take out a factor of 3. We have x plus 2. Notice if you did this correctly, you should have a common binomial factor. Then we can take out that common binomial factor. We have 2x minus 3 times x plus 2, taking that out, and that is our fully factorized equation. All right, that's all for today. I'll catch you guys in the next one.